Good afternoon, my dear friends. I'm very happy to start the quantum chemistry today. Actually, quantum mechanics, I wanted to reserve it till the college is reopened so that I can derive the equations on the blackboard. But as the time goes on, I wanted to start slowly so that you can also take a little more time and study books and you can understand by yourself. See, if you want to learn any subject, you have to learn the subject as how it is evolved. Any subject has its own evolution. See, in the beginning, there was nothing. So if you go to that nothing state and start from there, you start learning, you can very easily understand quantum mechanics. So in the beginning, people believed that everything was stationary. Nothing moves. Everything was stationary. Even there are people who don't know how to sleep. They will simply stand and they will fall asleep and then fall down. There are people without even the awareness of sleeping. Similarly, people were assuming that everything was stationary. Earth stands still. And then a scientist called Maupertuis, who is a French scientist, he was the first person to observe that planets are in motion. And that was the beginning of the mechanics. Mechanics means bodies, it is the study of bodies in motion. That is mechanics. Classical mechanics is the study of macroscopic bodies moving with velocity much less than that of light. The velocity of light is taken as the standard, whose value is 2.9987 into 10 power 8 meter per second. Any velocity which is much less than that of light. And also the motion is taken up by the macroscopic bodies. Macroscopic body means anything. Suppose a bullet from a gun or a moving vehicle or planetary motions. So these are all macroscopic bodies. So their motion with velocity much less than that of light. It is called the classical mechanics. And the study of the motion of a microscopic body, the bodies of the size of an electron, a light photon, a subatomic particle, or an atom, very small microscopic bodies moving with velocity much less than that of light. It is called the quantum mechanics. Quantization, quantum mechanics, quanta, small. The study of motion of macroscopic or microscopic bodies moving with velocity closer to that of light. Very close to that of light, whose velocity is very close to that of light, sometimes even greater than that of light. It is called relativistic mechanics. Relativistic mechanics. Actually, we are not going into the relativistic mechanics. We deal with the classical mechanics and the quantum mechanics. See, the classical mechanics, the waves and the particles are given separate treatments. Waves are dealt with separately and the particles are dealt with separately. But quantum mechanics treats the particles and waves altogether. So I want to present some of the slides of my writing. It will be very interesting to see. So look here. I've just defined the classical mechanics, quantum mechanics, and relativistic mechanics. And in the next slide, you can study this. Mechanics is the study of bodies or objects in motion. So according to the size or mass of the objects and their velocities, mechanics can be divided into three types. So classical mechanics, it is the study of motion of macroscopic objects moving with velocity much less than that of light. Quantum mechanics is the study of motion of microscopic objects moving with velocity much less than that of light. Relativistic mechanics is the study of motion of macroscopic or microscopic objects moving with velocity closer to that of light. So the next thing, look here, before studying the motion of a particle in space, please all of you mute your microphones. Some noise is coming. So before going to the movement of the particles in space, you have to understand the position of the body in space. The position of the body in space, which has to be noted down, that we need some coordinate systems to fix the position of a body in space. So there are three types of coordinate systems. One is called a rectangular coordinate system, where a point in space can be defined by three distances. Another one is a spherical polar coordinate system, where a point in space can be defined by one distance and two angles. Similarly, cylindrical polar coordinate system. The first, the Cartesian coordinate system or rectangular coordinate system, was proposed by a French scientist called Descartes. So look here, this is the rectangular coordinate system. In a rectangular coordinate system, there are mutually perpendicular three axes: x-axis, y-axis, and z-axis. The intersecting point of all these axes is called the origin 0, 0, 0, which is the reference point. So in Cartesian coordinate system, a point is defined by three distances from the origin point. So you need to know the origin. If you don't know the origin, then there is no relative distance between 2 points. So this point is the origin, is the reference point, and a point here can be defined by three distances. What is the distance from the origin along x direction? What is the distance of the point from the origin along y direction? And what is the distance from the origin along z direction? if these three directions, the distances in three different directions are known, then you can very easily fix the point. If the point is moving, then you can very easily say how far or what is the rate of motion in x direction, y direction, and z direction, which can be written as dx by dt or dy by dt or dz by dt. So first of all, we have to be very thorough with the coordinate system. Let us leave the movement alone. First of all, you fix the position of a particle or an object in space, where it is. Now, knowing the position itself is very important. Only when you know the position, then only you can think of the change in position. When you think of change in position, then you can relate that with the time. Then you can see what is its velocity. If at all it has a mass, the point has an object with a mass, then you can speak of the momentum. Then you can speak of the force acting on it. Then you can speak of the acceleration that it has. If it is a rotational motion, then you can speak of the torque. Then you can speak of the angular momentum. So these are all the dynamical variables you can speak of only when you know to fix the position of a point in space first of all. So fixing the position in space is the very fundamental thing, very much needed, and you have to understand the coordinate systems first. Next one. This is the second one, the spherical polar coordinate system. Here also we take three mutually perpendicular axes, and the point is taken as P here, and the distance of the point P from the origin. That's the distance. It does not depend upon any axis. You can simply take the distance. Whatever may be the angle or whatever may be the direction in which it is measured, you can directly take the distance, which is called polar distance. And the angle between the y and the object, it is called the theta, the polar angle. Suppose if it has a shadow over here, what is the angle? This angle, it is called azimuthal angle phi. So from this, you can relate the Cartesian coordinates and the spherical polar coordinates. They are related like this: x is equal to r sine theta cos phi, y is equal to r sine theta sine phi, z is equal to r cos theta. So this is how they are related. So distance between the distances and the spherical polar coordinate system. Next one, look here, the small volume element. So wait for some time. So look at the small volume element. This small volume element is d tau, which means when a particle is moving, if it is moving along x direction alone, watch closely. If a particle is moving along x direction alone, its position will change only in x-axis. Therefore, I can say it is only the change in one distance, that is a length. Suppose if it is moving diagonally about two axes, that is a dx is also there is a change, dy is also there is a change, means then I can say it is moving in an area. If it is moving diagonally, so that there are changes in x direction, y direction, and z direction, then it is called a small volume element. See, one direction, it is a small length element. Two directions, it is a small area element. In all the three directions, it is a small volume element. That small volume element is called d tau. That d tau is equal to dx dot dy dot dz in the case of Cartesian coordinate system. And also in spherical polar coordinate system, it is denoted as d tau is equal to r square dr sine theta d phi. And there is an operator called the Laplacian operator del square, which is equal to dou square by dou x square, dou square by dou y square, and dou square by dou z square. And the del square, that is the Laplacian operator in spherical polar coordinate system, is 1 by r square dou by dou r square dou by dou r, plus 1 by r square sine theta dou by dou theta sine theta dou by dou theta, plus 1 by r square sine square theta dou square by dou phi square. So these are all the fundamental ideas. Now, the motion of an object is described by many dynamical variables. Dynamical variables, they are the important physical entities which are very much essential to describe a motion of an object. The first dynamical variable that we are going to discuss is time. Whenever we speak of a dynamical variable, we should know its dimension and its unit. The dimension of a time is t, unit is second. Don't write SCC for second, that is a wrong expression. Second, small s, it is second. See, the time plays important role only in two branches of chemistry, chemical kinetics and also quantum mechanics. So these are the two areas where the time is found, which is one of the dynamical variables. Second dynamical variable is position coordinates or distances. So when a body is moving, automatically the position coordinates will change and the distances will change. If it is an angular motion, then the angles will change, the polar distance may change. Therefore, these are all the various positions. But these positions are subjected to change when the body moves. Therefore, the second important dynamical variable is position coordinate. See, x, y, z, r, theta, phi, etc. They are all position coordinates. And the third important dynamical variable is mass. What is mass? Mass is the total quantity of a matter. What is matter? Anything which has mass and which occupies space. So below certain level, you cannot define anything. The questions will get some kind of cycling repetition. If I ask you what is mass, it is the total quantity of matter. Then if I ask what is matter, anything which has mass and which occupies space. What is space? No one can define. Space, it is everywhere. Whatever you see is space. What is in between my hands is space. What is in between two electrons in an atom is space. What is between earth and the sun is also space. Space we cannot visualize. Where is the end of the space? No one can see. There's so many trillions of galaxies are there. So many trillions of stars are there in a galaxy. And we are living around a small star in a moderate sized planet. So when we compare the total volume of the earth with the total volume of the space, earth may be considered a small dust particle. It is a very small dust over which we are all sticking over the dust. We are all dust among the dust. We have nothing of our own. The earth itself, if it is blown into pieces, it won't affect the universe. It is one of the dusts, small dust particle. Therefore, mass is the total quantity of matter, and whose dimension is m, and whose unit is kilogram. In SI units, It is kilogram. It's the total quantity of matter. And the fourth dynamical variable is velocity. Velocity is distance traveled by time taken. Is the distance traveled by time taken, which can be written as velocity is equal to dx by dt, or it can be written as x dot. It is dx by dt, x dot. The dimension is length per time, L(t power -1), length per time. And the unit for velocity is meter per second. Meter per second. So velocity is also a dynamical variable. So it is distance by time, or dx by dt, which is also written as x dot. Dimension is length per time, that is L(t power -1). Unit is meter per second. Linear momentum is another dynamical variable whose dimension is m L t power -1. Unit is kilogram meter per second. Actually, momentum is mass times velocity. You should understand what is momentum. Suppose if there is a old bridge, you can see the speed breakers at both ends of the bridge, and you can see a notice is the old bridge goes slow. Then you should think, suppose a car of weight 1 ton with all its passengers is moving on the bridge. The total weight acting on the bridge is 1 ton. See, the weight is not going to change with velocity. Whether you are riding the vehicle fast or slow, the weight is going to be the same. Then why it is mentioned there to ride the vehicle slow? Even if you cross the bridge at the rate of 100 km per hour, the weight is going to be 1 ton. Even if you slowly move on the bridge, the weight is going to be 1 ton. Then why it is recommended to go at a slow rate? The reason is, what is actually acting on the bridge is not your weight, it is your momentum. How fast you are getting into that bridge, it is the momentum. It is something like striking a nail. Suppose a nail you want to strike in a wooden piece, you put the nail and put the hammer over there. Simply by keeping the hammer over the nail will never go inside. You have to strike. When you strike, actually what is working over there is the momentum. So momentum is mass times velocity. So when more velocity, how fast it is coming, you can think of a cycle accident. When you go in a cycle and hit on a wall, what is the loss? The loss will be very less, because number one, velocity is less. Number two, the mass of the vehicle is also less. Suppose, let me say, a cycle is traveling at the rate of 10 km per hour speed. At the rate of 10 km per hour speed, a cycle hit. You just to quantify the damage. Suppose if a big ship hits on a rock at the same speed 10 km per hour, see, the damage will be more, because rock, the mass of the ship is very high. Therefore, m multiplied by v, that will hit with very high momentum. Or even if you think of a train moves at the speed of 20 km per hour and it hits a person, the damage will be more. Suppose you take a mosquito. Your mosquito comes at the rate of 100 km per hour and hits you. Nothing will happen, because the mass is negligible. Therefore, when mass increases, momentum increases. When velocity increases, momentum increases. So momentum is mass times velocity. Momentum is mass times velocity. See, sometimes the birds hit on the aeroplane. An aeroplane is flying. If a bird hits on the aeroplane, that will cause a very big accident. The reason is normally an eagle or a crow or something, approximately, let us say, it weighs 5 kilograms. But what is the relative velocity? If an aircraft is going at the rate of 500 kilometer per hour speed, it is something like throwing a stone of weight 5 kg at the rate of 500 kilometer per hour speed. See, the momentum will be very high. Even aeroplanes will be broken down. So the momentum depends upon velocity and mass. So mass times velocity is the momentum. So mass, we know, velocity is dx by dt, that is the change of distance with a change in time, or the distance traveled per unit time. Therefore, I can write the momentum as mass dx by dt. Or I can also write mx dot, where mx dot means it is differentiated once with respect to time. So dot means that particular quantity is differentiated with respect to time once. If it is differentiated with respect to time twice, a double dot will be put. Therefore, momentum is mass times velocity. Next one is angular momentum. Angular momentum, the dimension is ml square t power minus 1. The reason is, look at the derivation which is given below. Angular velocity is omega, which is actually the change of angle with the time. See, linear velocity, linear means a straight line motion, linear motion. Angular motion means with respect to some point it is making an angular change. Suppose a ceiling fan rotating is the angular motion. A vehicle moving in a forward direction, it is called a linear motion. So for an angular motion, the ceiling fan is not moving anywhere, it is there. Its position is fixed, and it is rotating about an axis. So about an axis, it continuously changes its angle. If you are taking one blade as a reference, it is changing the angle about this axis. Therefore, I can say it is the change of angle with the time, or d theta by t, which is called omega. But we cannot speak of the mass here, because the actual weight is not shifted. Suppose if you consider a linear motion, then you can think of a mass shifted. But in the case of angular motion, it is not the mass, it is the moment of inertia. It is the moment of inertia means, it is, what is inertia? Inertia is resistant to move. The resistance shown by a body to move is called inertia. Certain basic definitions you should always remember. Suppose I am giving a small force on a body, the body is giving a resistance, and when my force is sufficiently higher, the body starts moving. What is that force which is sufficient to make the body just go? It is called inertia, the resistance to move. Similarly, the resistance to flow is called viscosity. Suppose you are allowing a fluid to pass through a small hole. What is the resistance shown by that fluid to pass through a particular small hole? It is called viscosity. So I is the moment of inertia into omega. So this omega is nothing but velocity into distance. So mass into velocity into distance. So this is called angular momentum. Therefore, r is a distance, velocity is a distance per time, mass is mass. That is why we are getting a dimension mass length square. One length is from this velocity, another length is from this r, therefore L square. So leaving the length, what is remaining is t power minus 1, therefore it is ml square minus t minus 1, t power minus 1. So this is the dimension of angular momentum. So what is acceleration? Acceleration is rate of change of velocity. Rate of change of its velocity is acceleration. It is also one of the dynamical variables. Acceleration is rate of change of velocity. Rate of change of a position is velocity. Rate of change of velocity is acceleration. Therefore, rate of change of position is dx by dt. That dx by dt itself is changing with respect to time, means there is another differentiation. D by dt of dx by dt. Actually, it is a dv by dt, which can be written as v dot. I have already told you, dot means differentiating with respect to time once. So it is v dot. So already dv is dx by dt. Therefore, d by dt of dx by dt is equal to d square x by dt square, which can also be written as x double dot. If the change of a position is double times differentiated with respect to time, you are getting the acceleration. Acceleration is rate of change of velocity. Suppose if a vehicle is traveling at the speed of 40 km per hour constant, there is no change in the velocity, then the acceleration acting on that body is 0. Suppose if I am raising the accelerator, in another 5 seconds, the velocity becomes 50 km per hour, means there is a 10 km speed change in 5 seconds. Therefore, the acceleration becomes 2 km per second square. So this is the idea. In 5 seconds, the velocity becomes 50 km per hour from 40 km per hour. Therefore, the difference is 10 km per hour, which changed in 5 seconds. Therefore, you can calculate this like this. So it is the rate of a change of velocity. Suppose if I say the acceleration due to gravity is a very important terminology. Acceleration due to gravity, which means gravity is providing acceleration to a body, and that acceleration is due to gravity. Suppose if you drop a stone down, that stone is falling down because an acceleration is acting on the stone, which is because of the gravity. So gravitational force is exerting acceleration on a stone. And the people have found out the value of acceleration due to gravity, which is equal to 9.8 meter per second square. Suppose if you go to a far distance and you keep a stone there, initially the velocity of the stone is 0 km per hour or per second, or 0 meter per second. It is stationary. If you drop the stone in first second, its velocity will be 9.8 meter per second. That means in 1 second, it will cross 9.8 meter. The second, its velocity will become 2 into 9.8 meter per second. Therefore, in another second, it will travel a distance of 2 into 9.8. In third second, it will travel a distance of 3 into 9.8 in 1 second, which means that the velocity of the stone will go on increasing in the order of 9.8 meter per second square. Suppose if the stone travels in the atmosphere from a far space for 1 hour, means you count, just to calculate what will be its final velocity when it reaches the earth. See, it is all beautifully designed. In the atmospheric friction, the stone will catch fire. That is why we are very safe from the meteorites. If at all a meteorite is entering into the Earth's gravitational field, automatically the Earth will start pulling the meteorite at a high acceleration, that is 9.8 meter per second square. Therefore, what will happen? The meteorite will approach, that will be moving towards the earth, and when it moves, its velocity will increase with the acceleration 9.8 meter per second square. The acceleration will increase the velocity to a greater extent. So when it reaches the earth, its velocity will be infinitely larger. So at that high velocity, due to the atmospheric friction, the meteorite will be burnt into ashes, and only the ashes will reach, even sometimes that ashes will be simply dissipated in the atmosphere itself. So we are safe. We are very safe as long as we are there in the place where God has put us. All right. So it's all because of the acceleration. And what is force? Force is another Force is another dynamical variable, which is mass times acceleration. Mass times acceleration. So look at its dimension. It is m l t power minus 2. How it has come? What is acceleration? Acceleration is l t power minus 2. You can look at here. Simply mass is added. Therefore, force is a kilogram meter per second square. Our force is nothing but rate of change of momentum. When you differentiate momentum as such, m is a constant which is not going to change with the time. Therefore, m into dv by dt. dv by dt is acceleration. Therefore, I can write d by dt of p, that is the rate of a change of a momentum, is acceleration. So this momentum can be mentioned like this, d by dt of mv. So m into dv by dt can be written as mv dot. So which can also be written as mx double dot, or it can also be written as p dot. So it is the rate of a change of a momentum is a force. Force acting on the body. Rate of change of momentum is a force. I think it is now it's the time. So it is 1:20. I think with this we can stop, and the rest of the things we see in the next class. Shall we continue or shall we stop?